Hello, so today we are going to have an example on estimation of the population variances using the F-test or F-distribution. So this here on the upper portion is our working formula. And to get the lower bound, so we have the standard variance of the sample, first set of sample, and the variance of the second set of sample multiplied by 1 over the critical value of f at degrees of freedom 1 and degrees of freedom 2 for a certain confidence level, or the alpha over 2. And to get the upper bound, we get the ratio of the first set of samples variances in this variance of the second set of samples multiplied by this f critical. So for the difference, we consider in the lower bound the degrees of freedom of the first set of samples as numerator and the degrees of freedom of the second set of sample as our denominator. On the other hand, if we are going to get the upper bound, we consider the degrees of freedom of the second set of samples and the degrees of freedom of the first set of samples as our denominator. So we are having here our examples, and we have N1 as 43, mean of the first set of samples 604, and the variance is 4103. For the second set of samples, we have 107, the mean is 633, and the variance, sample variance is 10,670. So we are going to estimate this ratio of the two population variances. So we assume a 95% confidence level. The first thing that we are going to do is to get these critical values of f. So for the lower bound, we have this f alpha over 2, degrees of freedom 1, degrees of freedom 2. And for the upper bound, we have degrees of freedom 2, degrees of freedom 1. So we have a 95% confidence level. So we can now have our alpha as 0.05, and thus as our alpha over 2 is equal to 0.025. So by looking at our f table, this will be equal to f of 0.025. Then we have degrees of freedom for the first set of samples. Degrees of freedom is equals to n minus 1, so we have 42, and then 106, and then here we have 106, and then 42. Okay, so these are the numerator and denominator values that we are going to consider in looking for the f critical value using our f table as shown. Okay, so looking at our f table, we have got the value of 1.64 and 1.72. Okay, so we now have our critical f 1.64 and 1.72. So we can now solve for our lower bound and our upper bound. So for the first variance, we have 4,103, and the second variance is 10,670. So multiplied by 1 over this critical value 1.64, and thus we have our answer as 0.2344. So to get the upper bound, still we have 4,103 divided by 10,670 multiplied by our F critical, which is 1.72, and thus we have an answer of 0.6614. So this means that the estimated value of the ratio of our population variance is between 0.2344 and 0.6614. So this will be our estimated value for the ratio of the population variances. Okay, thank you very much.